Okay, so looking at example 3.4, we're looking at some rule or something called Struton's rule, which is basically an empirical rule which was seen from a lot of experimental values that says that the molar entropy of vaporization, let me just rewrite that, of vaporization is about 85 joule per Kelvin per mole. Right. And then from that, we can use that to predict what the enthalpy of vaporization would be using equation 3.15. I'm just rewriting it a little bit. So in other words, taking that delta S, I'm just writing it in shorthand, is equal to delta H over T. So then, of course, you just essentially, you take the T to that side, and of course you get the delta S value in here. And that's how we get to there. And this value is, if we then calculate this, it's actually quite close to the experimental value of 29.45, which is to be expected because this rule works well as long as we have something that does not consist of hydrogen bonding networks. So in other words, we're working with bromine, which is not something that contains a lot of hydrogen bonding. So if we had something like ethanol or ethanoic acid or water, that kind of substance or these kinds of substances, then Struton's rule might not be as applicable. And the reason is because once you have a larger hydrogen structure, so in other words, if we just think about water, which has something, this bent structure, which then, hydrogen bonds to an oxygen, which then has its own hydrogens again, then you have an increase in the required energy, if you want to put it as such, to break up these bonds. In other words, it makes sense that you would require a higher vaporization energy than necessarily would be able to predict from a very, what would you call it, constant model. So it doesn't really take into consideration this kind of interaction necessarily. It just allows for all molecules without any intermolecular interactions. So the moment you have hydrogen bonding, then the rule sort of falls flat. You can read up about it more in Atkins. There's a short section on it. The Wikipedia page is also quite helpful on it. But this is just essentially to make you aware of the rule, that it is something that might come up somewhere, or it might never come up again and you will forget about it. Okay.